Hello students, today we will be solving the IB Math AHL May 2025 paper 1 tension 3 question number 12. This is the last question of this paper. You will be getting the solutions for the first 11 questions from this paper and the solutions to the other questions from the other past papers in form of playlists on my channel NS Online Math Tutoring Classes. You will also be getting playlists where the solved past paper questions will be available based on their topics. I'm Nilanjana Sanyal. I'm an online IB Math AHL level tutor. You can get my phone number and my website address at the bottom of the screen. So without any further delay, let us start to answer this question. Number 12, the maximum mark is 21. Consider the complex number z equal to x plus y I, where x and y are real numbers and the modulus of z minus 2 plus I is equal to 3. Subpart A's question is show that x square plus y square minus 4x minus 2y minus 4 is equal to 0. Now, from where can I get this question, this equation? We are given only this information and from here I have to somehow get this equation. So let us start. We do not have any other option. We will be starting from this equation, given equation, and we will be finding the modulus of this. So, z equal to x plus yi. Therefore, in place of z, I am writing x plus yi and I am expanding this. So, it is minus 2 and minus I equal to 3. And now I will be grouping the real and the imaginary parts. So, it is x minus 2 and plus y minus 1 I equal to 3. So, therefore, it should be x minus 2 whole square plus y minus 1 whole square, and the square root of this should be equal to 3. And if we square both the sides, because I want to get rid of the square root, I get x minus 2 whole square plus y minus 1 whole square is equal to 9. Because there is no square root in this equation and also there are x square and y square. So, this indicates that we have to take the square root of both the sides. Okay. And now I will be expanding. You can use the identity a minus b whole square. I am using the identity a minus b whole square. In case you are confused, you can multiply x minus 2 with x minus 2 term by term. Okay. So, x square minus 4x plus 4 and plus y square minus 2y plus 1 is equal to 9. And since the right hand side of the equal to sign is 0, I am subtracting 9 from both the sides. So, it is x square plus y square minus 4x minus 2y, and 4 plus 1 is 5 minus 9 is minus 4, and 9 minus 9 is 0, so this is 0. Okay, so we have got this equation. Shown. The argument of z plus p over z minus 1 is pi over 4, where p is a real number. Subpart B, show that x square plus y square plus p minus 1 times x plus p plus 1 times y minus p is equal to 0. Okay, again we have to show this equation. We have to come to this equation from the information that has been given to us. Z is x plus yi. Okay, so let us see what happens. I'm starting with this. So it is z plus p, I'm writing z plus p over z minus p, z minus 1 rather, is equal to x plus yi plus p, and this one is x plus yi minus 1. Okay, and I can group the real and the imaginary parts. So it is x plus p plus yi, and it is x minus 1, and this is containing 7 marks, you see, x minus 1 plus yi. So if we can solve this, we'll be getting 7 marks. Okay, so now we have to, no, we are given that the argument is 5 over 4, but we have to get the expression of the argument of this complex number. So there is a complex number in the numerator, there is another complex number in the denominator. So there is two complex numbers are getting divided. So how do we divide complex numbers? We multiply with the numerator and the denominator by the reciprocal, or not the reciprocal, rather the complex conjugate of the denominator. Okay, so I am doing that. X minus 1 and minus yi over x minus 1 and minus yi. You may say that why should I be doing, even at this stage I have no idea. I am given z plus p, so I have done z plus p and I have just collected the real parts, the terms which are real together, and the imaginary part is kept separate. And for the denominator also I have done exactly the same thing, and I am seeing the two complex numbers are getting divided. So the way we perform division of complex numbers or two complex numbers, I am doing exactly the same thing. Okay, so let's see what happens. And now I can multiply term by term. It is x plus p times x minus 1 and minus x plus p yi and plus x minus 1 yi and minus y square I square. Okay, over, it is a plus b and a minus b, so it is x minus 1 whole square minus yi whole square. Okay, so this is equal to, I can okay, let me keep it this way. I do not know whether I have to expand the whole thing. Yes, I do have to expand. So because these are all fine. So let me expand. X square minus x plus px, because I'm having px, I'm seeing, so px minus p and minus xyi minus pyi plus xyi minus yi, and I square is minus 1, so minus of minus is plus, so it is plus y square. Okay, so this is the numerator. And what about the denominator? It is x square minus 2x plus 1, and this is I square is y square, I square is negative 1, so it is plus y square. Okay, and now I am separating the real and the imaginary parts. Always separate the real and the imaginary parts, it makes things simpler. So I see these two can get cancelled. These are the only two terms that may get cancelled. Okay, fine. So, and over here I can take, they have taken plus p minus 1. This is what you have to notice. What have they taken? P minus 1 and there's a plus sign. So I'll be doing exactly the same thing. Okay, so it is plus, I'll be taking these two, plus p minus 1 x, and then I can take these. Okay, and over here I am seeing it is p plus 1. Of course, I'll be getting a negative sign over here, but anyway, I am keeping the expression within the bracket as p plus 1. So I have taken this one, I have taken this one, I have taken this one, I have taken this one. Now this and this, these two are remaining, so it is, I can write plus y square and minus p. Okay. P plus 1 I y, and I should be keeping this I also. Okay. But I have not separated the real and the imaginary parts totally. I just combine the terms over here. So let me keep it this way. Okay. And now I can separate the real and the imaginary parts. So it will be x square plus p minus 1 x, and it is, there is y square and p. Yes, they are there. And plus y square minus p over x square minus 2x plus 1 plus y square. In fact, you may keep the denominator as it is. You do not actually need to expand the denominator. It will be ultimately getting cancelled. I'm showing you how will they be getting cancelled. Okay, but right at this moment, I am separating the real and the imaginary parts. So it is plus, it is not in fact plus, it is a minus. It is minus p plus 1 yi over x square minus 2x plus 1 plus y square. Okay. And now they are saying that the argument is pi over 4. Argument means theta. We take tan theta equal to, where theta is the argument, and we get, if the complex number is x plus iy, and how to find this argument? We write tan theta equal to y over x. We take the imaginary part divided by the real part. That is how we find the argument. This is theta, and then we take the arctan or tan inverse of both the sides. Okay. So what we can do is, we can write tan theta is equal to, theta is the argument, tan pi over 4, which is equal to 1, is equal to minus p plus 1 y over x square minus 2x plus 1 plus y square. This whole thing, this is the imaginary part, divided by the real part, x square plus p minus 1 x plus y square minus p over x square minus 2x plus 1 plus y square. Okay. So, or this is equal to 1 equal to minus p plus 1. Sometimes I am writing two steps in one line, like this one and this one, because otherwise I have to go more down. But it is obviously assumed that the students will be writing the equal to sign one below the other. Okay. So it is minus p plus 1 I x square minus 2x plus 1 plus y square multiplied by x square minus 2x plus 1 plus y square over x square plus p minus 1 x plus y square minus p. Okay. And now these two can get cancelled. That is why I had said that you don't have to actually expand the denominator. They will be getting cancelled, the two expressions. Okay. For the real and the imaginary parts. And so this is equal to, again I am writing it over here. It is x square plus p minus 1 x plus y square minus p. Okay. So now I can cross multiply, or I can simply multiply both sides of the equal to sign. On the left side, I'm having 1, and the right side, I'm having this expression. So I can multiply the entire equation by this denominator. Okay. So I get x square plus p minus 1 x plus y square minus p is equal to minus p plus 1 y. Okay. Or x square, how did they write the terms? X square, then y square, then x, and then y, and okay. So x square plus y square plus p minus 1 x, and now it becomes plus because I'm adding p plus 1 y to both the sides. So it is p plus 1 y, and then minus p is equal to 0. Okay. This is exactly the thing that they have asked us to show. And so we get full 7 marks. Okay. It is that easy. So easy to get 7 marks. Just follow your concept. When you start to solve this question, you may not have any idea about how to come to this equation. But just go on solving, go on expanding or dividing, whatever you have to do it, and you will eventually come to this equation. Okay. It is shown. Two roots of the equation z to the power of 4 plus a z cube plus b z square plus c z plus d equal to 0 are z1 and z2. It is a polynomial equation of degree 4. The two roots, there will be the other two roots also, z1 and z2, where z is a complex number and a, b, c, d belong to the set of real numbers, means these all the coefficients are real numbers. So therefore z1 star and z2 star will be the third and the fourth roots. Okay, the complex conjugates of these two. Both z1 and z2 satisfy the conditions, the modulus of z minus 2 plus I equal to 3 and real of z plus 4 over z minus 1. Over here it was z plus p over z minus 1. So in fact the value of p is 4. P is a real number, so p's value is in this case 4. The real part of this is equal to the imaginary part, that is z of z plus 4 over z minus 1. Subpart C, again containing 7 marks. Use the results of both from parts A, that means we may use this equation, and part B, so we may use this equation also, and argument is pi over 4. All these information can be used and should be used to find Z1 and Z2. Okay. So I have brought this question down. This is subpart C. Okay. As we had seen that P's value is equal to 4 over here. Okay. And they are saying that these two conditions are met by Z1 and Z2. From this condition, we had found this equation. Okay. So I can write this equation. This equation will be satisfied by both Z1 and Z2. So I'm taking this equation. And for this, for subpart B, they had said the argument of this is pi over 4, and for subpart C, they are saying that the real part is equal to the imaginary part. Real part is equal to the imaginary part means y over x tan theta is equal to y over x. Okay, when the complex number is x plus yi. When y is equal to x, then tan theta will be equal to 1, and tan theta equal to 1 when theta is either equal to pi over 4 or theta is equal to, means it is from the either from the first quadrant or from the third quadrant, the angle, corresponding angle will be 5 pi over 4. Okay. So since they are saying that the imaginary part and the real part both are equal, then we can take this condition that is over here given, that it is pi over 4. Even when the argument is pi over 4, the real part will be equal to the imaginary part. Okay. So I'll be using this equation, which was the Subpart B's equation, which we had to show. Because they have said use the results from Subpart A and Subpart B, I am not taking the condition of theta equal to 5 pi over 4. Okay. I do not know. I have to check whether theta equal to 5 pi over 4 gets satisfied in this case or not. I have to check, but I am not going to this detail because I don't want to spend more time. They have said that real part and imaginary parts are equal, and over here I am seeing theta equal to pi over 4, and they are asking us to use the Subpart B. So I'm using this equation. Okay. And only thing that I'll be changing is in place of P, I will be writing 4, because it is Z plus 4 over Z minus 1 in place of Z plus P over Z minus 1. Okay. So x square plus y square, 4 minus 1 is 3, so 3x, and 4 plus 1 is 5, so plus 5y, and minus 4 is equal to 0. Okay. And now we can use the method of elimination, because this is also a very important method. Many students always go for substitution, which is not the most appropriate method in some situations like this one. Okay, you cannot substitute the expression of y, means you cannot express y in terms of x or x in terms of y because of these square terms. So in these cases, elimination method is of course the better method, better option. Okay, so this is equation number 1, this is equation number 2. I'll be doing this operation 1 minus 2. Okay. So since I am subtracting, all the signs of the second equation will be changing. And now we will be adding, so x square minus x square cancel, y square minus y square cancel, minus 4 and plus 4 cancel. So I get minus 4x minus 3x is minus 7x, minus 2y minus 5y is minus 5y, sorry, minus 7y, and is equal to 0. And I can divide the entire equation by negative 7 to get x plus y is equal to 0, or y equal to negative x, or x equal to negative y, anything. Okay. So y equal to negative x. If I substitute negative x in place of y in any of these two equations, I'll be getting an equation having a single variable. It will be a quadratic equation, so I can solve that. So let me take the equation number 1. You can take equation 2 as well. So substituting, three in 1, it is x square plus negative x whole square minus 4x minus 2 times negative x, and minus 4 is equal to 0. So it is x square plus x square minus 4x plus 2x minus 4 is equal to 0, or 2x square minus 2x minus 4 is equal to 0. Dividing the entire equation by 2, we get x square minus x minus 2 is equal to 0. Okay. So this is x square, and I can write plus x and minus 2x and minus 2 equal to 0. So x plus 1 and minus 2x plus 1 equal to 0. Therefore, x plus 1 times x minus 2 equal to 0. Therefore, x equal to -1 or x equal to +2. Okay. So when x equal to -1, y will be equal to +1. So therefore, this I'm writing this as z1. This can be z2 also. Z1 is equal to -1 plus I, because y's value is 1 plus 1, and z2 is equal to, since x equal to 2, y will be equal to -2, so it is 2 minus 2i. These are two complex numbers. Find z1 and z2. They have not given any information about z1 and z2, which one to call z1 and which one to call z2. So I have written z1 as -1 plus I and z2 as 2 minus 2i. Okay. So we have solved this subpart C. Okay. Subpart D. Find the value of A. A is over here. So what will be the, how to find this A? It is, if we write the standard form of a polynomial of degree 4, it is A x to the power of 4 plus B x to the power of 3 plus C x to the power of 2 plus dx plus E is equal to 0. This is the standard polynomial of degree 4. So over here, if I relate this equation with this, I'm seeing the A's value is 1 and B is equal to A. Okay, and we know that the sum of the roots, there will be 4 roots of this polynomial, and the sum of the roots will be equal to minus B over A. A in this case equal to 1 and B is equal to A. So the sum of the roots should be equal to minus A. Minus B means minus A. Okay. So we will be using this, but what will be the sum of the roots? Because we have found only 2 roots. We have to find the other 2 roots also in order to get the sum of the 4 roots. For that, we will be using this property that all the coefficients are real numbers. Okay. So, subpart E, since A, B, C, D are all real numbers, therefore, Z3 will be equal to Z1 star, that is the complex conjugate, which is equal to -1, -I, and Z4 will be the complex conjugate of Z2, which is equal to 2 plus I, 2 plus 2I. Okay. So therefore, sum of the roots equal to -1 plus I plus 2 minus 2I plus -1 minus I plus 2 plus 2I should be equal to negative A over 1. Okay. So this implies this is -1, this is +2. So 2 minus 1 is 1. 1 and -1 is cancelling, it is 0. And then there is this 2. Fine. What about the imaginary portion? I minus 2I, so I am having minus I, and minus I is minus 2I plus 2I is 0. So 2 is equal to minus A, or A is equal to -2. Okay. So this completes our answering of this question. Thank you for staying with me till the end. Please like and share this video in case you have liked my explanation, and please subscribe to my YouTube channel. Your liking, sharing and subscribing will be really helping me a lot. We meet again very soon. Till then, bye.